Hi, in this audio, you'll hear a recorded conversation between me, Shadea Mc David, and my colleague, Mrs. Karla Williamson, a math teacher and head of department of mathematics here at Northgate College. This conversation is part of our collaboration for a multidisciplinary lesson of motion in physics and travel graphs in math, and will serve as evidence of our planning together. I'd like to note that this recording is being used with her permission and will be submitted as part of my curriculum integration portfolio for the Diploma in Education. Hi, Mrs. Williamson. Thanks so much for agreeing to do this recording.
Hi, Shadea. You're welcome. And no problem. Always a pleasure to assist in this type of collaborative work.
As part of my diploma in education, I'm preparing a physics lesson on motion graphs, specifically displacement-time and velocity-time graphs. So since you are teaching travel graphs in math around the same time to the same group of Form 4 students, I thought it would be really helpful to coordinate what we're doing. I'd love to ask you a few questions to better understand what you're covering, so I can build on it in my lesson and show how the both subjects connect under the same theme. All right?
Okay, sure. Go ahead.
So I know that travel graphs comes up in Form 2. So why then do you revisit it in Form 4?
So travel graphs is revisited in Form 4 or sometimes Form 5 because the last time the students would have done it will be when they met it in Form 2. In Form 2, however, when they are now learning it, a big part of the topic then is covering calculations, as in, just word problems involving finding the distance given speed and time and, finding any of the other variables. Again, at this level, we also spend some time doing conversions. So they have to convert units, convert time. So while they meet travel graphs in Form 2, it's also focused on interpreting the graphs because graph work takes time for students. They don't always grasp graph work easily. So in Form 2, they use a lot of like grid lines, and sometimes you have set scales, they're given the scales on the graph and stuff like that. They're given grid lines that are already drawn up so that they are focused on interpreting the graph, knowing how to read what the distance is for a particular time, what the time is, how long it took for a particular journey to be covered, and also just being able to understand that to find the average speed on the graph, you actually have to calculate it because you can't read the speed off of the graph. So that topic is revisited a bit in Form 4 because of the 2-year gap between when they just did it, so that in the lead up to doing speed time graphs, they're able to reference or be reminded of the foundation that was laid in Form 2.
All right. So where exactly does this topic fall in the math curriculum? And what key objectives or learning goals are you aiming to cover with the students?
This topic falls under the Relations, Functions, and Graphs section of the CSEC syllabus. The key objective is to get them to interpret the graphs correctly, as in, of course, if you're given a graph, be able to answer questions on the graph, but also be able to draw a graph based on information given.
What particular textbook or materials are you using to teach the students with?
In terms of materials to teach this, I will use a combination of things, a video, as well as a PowerPoint presentation to reinforce stuff in the video, the key objectives in the video, and then the textbook we will use to work through questions to practice it. So video, PowerPoint presentations, and the textbook. So because they are Form 4 students, we use the Volume 1 and Volume 2 text by Raymond Toolsey. This topic will most likely be mainly covered from the volume 2 of the Raymond Tulsi Mathematics, a complete course for CXC.
All right. Well, then, can you walk me through what your lesson will look like? So, exactly what would you cover with them, and how would you cover it with them?
Okay, so a lesson like this will probably start with a bit of review because the content is not new to them. I will try to find out from them, from the students, what they remember about distance, speed, or time, even in terms of the units, or if anybody can give an example of, like a real life example of any of it with character games, just finishing recently. If the students are able to talk about races and, just anything that in their context they can use to connect the terms distance, speed, or time. So they'll start with a bit of discussion to hear what they remember, if they remember the units, and maybe, just do a little bit of conversion with them or something like that. So, what is 30 minutes in terms of hours or 90 minutes in terms of hours, that type of thing. I would probably then do or show a video, because I always think they're nice YouTube videos showing a visual of a distance time graph. And so in the video will just run so I will find a video that gives a story where the person is relating the journey of someone and showing the graph coming up. And I will use that because at the end of that will present a completed distance time graph to, just reinforce things about distance on the y-axis and time on the x-axis, to talk about, the scale, like every centimeter. So just to reinforce that type of thing, or remind them of those aspects of distance time graphs. And then I will probably use that same completed graph to compare, not to ask questions to them about various aspects of speed, distance, and time. So the first part of the class will be very interactive, to see the extent to which they remember the aspects of speed, distance, and time, and interpreting the travel graphs. We will then use the textbook, the volume 2, and work through a couple questions together, as in I'll go around the class and have different students answer questions on the distance time graphs. So just questions requiring interpretation first, and then we will use the graph paper and do questions where they have to draw the travel graphs based on information given.
Okay. So, based on what you said earlier and just now, my understanding now is that you do both distance time and speed time, whereas then I would have thought it would have been just distance time alone. So can you just go into that a little bit more?
Both distance time graphs and velocity time graphs will be covered. More time is spent on distance time because once they're able to grasp the key aspects of distance time graphs, then when velocity is introduced, the minor changes or the differences in the two graphs can be shown, and most times the students have a better appreciation of velocity time graphs after having done the distance time graphs and that covered well.
All right, lovely. So both type of graphs. Okay, so how do you usually explain what the slope or the gradient means on these graphs?
When they do distance time graphs in Form 2, we don't mention gradient of the line. However, because gradient is covered as part of the straight line graphs topic in Form 3, by the time they get to Form 4, they understand that the slope or the gradient of the line is the change, the vertical change over the horizontal change. So in Form 3, when we're doing straight line graphs, that is drilled into them so they understand that change is what gives you this slope, a number that represents how steep the line is. In Form 4 then, when we do the distance time graph and we now put and the axes are no longer just X and Y as in Form 3, they are able to see that the vertical change is a change in the distance and the horizontal change is a change in the time. And that is connected to the formula they learned in Form 2, which is that speed is distance over time. So that connection is made so they understand that the steepness of the line is the gradient or the slope, and that allows us to determine speed. So of course, the steeper the line, the faster the object is moving. If the line isn't as steep, the object isn't moving as fast. So those terms are used, and that's how we'll explain what the slope or the gradient is on the graph. So it's connected to the Form 2 stuff and then the Form 3 stuff, and so that you can see it better by the time they get to Form 4. It hopefully makes a little more sense.
All right, and are there any common mistakes or confusion students usually have when reading or drawing these types of graphs?
Being able to interpret scales on a graph, the scales on the axes, or I guess most times students are better at drawing the scales if they're given, use a scale of 2 centimeters to represent 1 hour. They are able to set that up in drawing the graph. I find a lot of times when in terms of interpreting the graphs, given a scale, sometimes it takes students a while to know what each centimeter represents, depending on the scale given. So whether a centimeter will be 15 minutes, or maybe a centimeter is half an hour, or a centimeter is an hour, depending on the scale given, and to be able to apply that properly to the question. So that is what I would say would be some of the common mistakes or confusion when they're reading or drawing the travel graphs.
Okay, yeah, I identify with that. Scale work is something that even in physics, it is really confusing for the students. All right, well, then what kind of examples or activities do you use to help them really get it?
To help them really get it, a combination of worksheets can be used, and also, as I said earlier, the textbook exercises. And because they're in Form 4, I also like to start pulling on CSEC past paper questions so they can start to see how CXC will test questions like this. And it kind of helps to build their confidence when they realize, oh, I can actually answer past paper question on this. So that's what's done to get them to help them to really get it. I think doing the past paper questions, it works as a confidence builder when they realize that they can actually answer the questions.
All right, so I will take photos of the textbook, etc. But I wanted to know, how do you usually check if they understood what the graph means? So like, do you quiz them or use exit slips, that sort of thing? What exactly do you do?
To ensure that they really get it, so which is why I like class to be a combination of things. So even if we start doing with a discussion, asking people, individual students, questions about a graph that's either being presented by PowerPoint, or even if it's a worksheet question and people are answering, taking turns answering, at some point in time, the work has to become individual work so that each person can know if they understand the thing and they're not just riding on the strength of the class. And so it's at that time I will walk around and correct books, or have people come up to my desk and actually correct their work, especially for the drawing of graphs part, because once they start drawing graphs, I need to see that they are doing this stuff properly. So some people will draw the axes but not label it, and all those little things I'm able to pick up from individual students. So I don't use exit slips, but I definitely plan so that before they leave, in most cases, everybody is able to do a particular question and have it checked by me, to make sure that they understand what was done in the class. Quizzes, using a quiz I do that at times, but again, it depends on the length of the class, how much time I have. If not done in one session, it might be done in another session. I can, so even if in one class they, work through some on their own, they will get homework to practice, and then the next class can start with a quiz or something to see if they're still able to apply what they've learned.
All right, and last question. And just overall, how do you think learning travel graphs in math help the students when they meet motion graphs in physics later on?
I think learning the travel graphs in math will definitely be a good platform from which to teach motion graph in physics. And if they're able to remember the basics or the concepts of travel graphs, I think it should be it'll be good for them to now apply that to another context and see how some of their syllabus, the content in the syllabus can be applied across various disciplines.
Okay, so I have all the information that I need to plan my class. Thank you very much.